Hello. Yet again, silly question. To be very precise, silly questions. There are two questions. Actually, answer for both is same. So that is why I have considered both of them in single video. Well, most of the time students have this question. Few of them ask, few of them just uh, strangulate this question in their mind, in their heart. Yet I know that this question should be answered. We know that there are two types of charges, positive and negative. But how have we decided that this particular object is positively charged? Or if directly I talk about electron and proton, then how have we decided that electron has negative charge? Why, for the sake of convenience, we haven't considered electron to have positive charge? Then I think at least direction of current was become simple to explain. Anyway, the story begins uh, with the ancient Greeks. One thing I want to clarify that I'm not going to explain on the quark model or quantum mechanics or electrodynamics on that way. It is just a simple history how sign convention, positive negative, has introduced. All right. Since 600 before Christ, Greeks have observed electrification of ebonite, amber, hair, etc. So, actually, it is evident in all other places. It is also possible that they have seen this kind of electrification. But Greeks, we have evidence that 600 before Christ, Greeks have encountered with the electrification. I mean, they observed a new kind of long distance force. So, at that time, they were unable to explain this phenomenon. So many theories were there. Uh, and well, they observed many things, and they have seen the different type of electrical behavior of different material. Take an example. Actually, it didn't happen, but I'm considering it as a case how we required a classification of two types of charges and then sign and all that. So let us assume an experiment. I have an object, amber, and fur. Next time I will write just A and F. So they rubbed amber on fur, and they later on, when they brought amber close to fur, they saw a kind of attraction. Okay, now there are two possibilities because they have just given it the name electrification or similar kind of. So it was just they believed that either of these two substances are getting electrified. So there are two possibilities: either amber is electrified and fur doesn't have any charge, or vice versa, amber doesn't have a charge and fur is electrified. Okay, again, uh, ebonite and fur. Fur. So they rubbed ebonite rod on fur, and again they have seen kind of attraction. Again, there are two possibilities: either after rubbing, either ebonite rod is positively charged and fur is uncharged, or ebonite rod is uncharged but fur is charged. Okay, now they brought amber and ebonite close to each other by some ways, by threading up, I mean, just hanging them by threads. And what they have observed, here we have amber after rubbing, okay, after rubbing with fur, amber and ebonite, still they saw attraction. Now, uh, well, it implies either amber is charged, ebonite is not, or ebonite is charged, amber is not. But from above two conclusions, we can conclude that both ebonite and amber both are getting charged. It means they have some different kind of charge. Moreover, they have seen that after rubbing, amber repels amber, ebonite repels ebonite, and some other materials also. They repel each other also. So the decision was made that instead of one body getting charged, there are two types of charges. And now I don't know what were the names initially given, but now we can say that there are, when we have two categories, two types of charges, might be they were given name up down, high low, love hate, fat thin, or whatever you can say. But in the similar way we can say positive negative, and it's look more mathematical, it's look more scientific. So the sign convention positive negative were accepted. Here I just want to add into your knowledge that when amber is rubbed with fur, so amber get positively charged and fur get negatively charged, whereas when ebonite rod is rubbed with fur, ebonite rod gets a negative charge, where fur gets positive charge. So this thing also happen. Okay. um, Later on, everything was messed up when Benjamin Franklin gave the idea of charge as a type of invisible fluid that could build up or be absent from a material. I mean, if there is that fluid, he just imagined that if this body has that fluid, and this does not have that fluid, it has something in excess, that is positive, it has something in lack, that is negative. And then he said that due to the flow of this imaginary liquid, that electrification happens. So later on, on the basis of that, he just decided that how current would flow, how current flows actually. Till then, the idea of current was introduced, and how current will flow, he just gave this idea that this positive fluid flows. Later on, what we were just imagining, what we were taking into account, like we have devised actually in the 18th century, we got that electric cell, and on the basis of this electrification, we have given its one of the terminal as positive, other terminal as negative. And later on, when there was the discovery of electron by J.J. Thomson, all of a sudden everything was changed. Like we observed that from negative terminal, it is negative, from negative terminal, I mean cathode rays are being emitted. So those were called electrons. So electron, because they are emitting from negative terminal, so they are considered as negatively charged. Later on, it came to know that only electron can flow, and so also in the cells, electrons, actually electron flow from this negative terminal toward this terminal. And earlier it was believed that positive terminal is responsible for the flow of charge, that is positive charge. So that is why it is a confusion that we encounter with, like direction of current. It is the direction of direction of current is the direction of flow of electron, opposite to the direction of flow of electron. I repeat, actually I think I have just messed up with the statement. Direction of current is opposite to the direction of flow of electron. So this is the entire scenario. So that is how we have came to the conclusion of a body having positively charged or negatively charged. Here I want to put my opinion that if electron would be considered as positive, what is the point in that? Then proton would be negative. So there is not a big trouble, big problem by assigning some objects as positively charged or some objects as negatively charged. Actually, the positive or negative charge doesn't mean that positive is better, superior, or having greater stand. It doesn't mean that. This is how till today we use these signs, and now I'm signing off. Bye bye.